Welcome to Study Loop.
So in this question, we'll see that air is flowing in subsonic velocity and is accelerated by heating. So for a specified exit Mach number, we have to find out the heat transfer as well as the maximum heat transfer rate. So considering this question, we understand that certain assumptions has to be taken. And the first assumption that we take is all the assumption that is related to the Rayleigh flow has to be taken. And second is that inlet conditions have to be constant. Now, we understand that we are taking air and the properties of air we have to consider. A is equals to 1.4, Cp is equals to 1.005 and R equals to 0.287 kilojoule per kg Kelvin. So the inlet Mach number and stagnation temperature we have to see. So for that, first we have to find out C1 and that is equals to KRT1, which is equals to 400.9 meter per second. Here then we have MA1 that is equals to V1 upon C1, which is equals to 0.2494. From here the stagnation pressure temperature we have T01 is equals to T1 into 1 plus K minus 1 upon 2 into MA1 square. Now that is equals to 405.0 Kelvin. So the Rayleigh flow functions corresponding to the inlet and exit Mach numbers can be taken from our table A34. So for that condition, MA1 is equals to 0.2494. Hence, the Rayleigh flow function that T01 on T0 star, that is for inlet, is equals to 0.2559. And then we see that MA2 equals to zero point 0.8. So T02 upon T0 star equals to 0.9639. So considering this, the exit stagnation temperature, that is T02, that can be found out by this equation, that is T02 upon T0 star divided by T01 upon T0 star, and that is equals to 0.9639 upon 0.2559, and that is equals to 3.7667. Hence, we get that T02 equals to 1526 K. So the heat transfer at this condition, Q is equals to Cp into T02 minus T01, that is equal to 1130 kilojoule per Kelvin, kilojoule per kg. And this condition, when Ma2 equal to 1, then T02 upon T0 star equal to 1, then we get that we have to see the functions here. T02 upon T01 we have to find out, and that is equals to 1 upon 0.2559, and that T02 equals to 1583 Kelvin. Considering this, we see that Q max, the same value for Q, 118 approximately. I hope you understand.